welcome back to another video of the channel. My name is Julio. Thanks for tuning in. Before we get started, like, subscribe, hit the notification button, and let's get down to business. So today we're going to be talking about BGP attribute local preference and what path manipulation mechanism it provides to your network. Let's get inside the details. So BGP local preference is an attribute that helps determine which path is best for traffic to take through an autonomous system. It's a common technique for manipulating paths in networks. So how it works? BGP local preference is exchanged between all BGP enabled devices in an internal BGP network. The default value is 100 and higher values are preferred over the lower values. Local preference is used to configure an AS to select an exit point. Local preference is a strategic tool for managing traffic across an AS. When it's used, when the same subnet mask prefix is advertised from multiple links to control outbound traffic from within an AS to focus on internal priorities and preferences. All right, so here's our network topology. We got on the left side the carrier router, and we got on the right side the customer router. We are going to be running two links to the same provider, and this is what's going to happen. All right, so here at the right side, we got the customer router. We got two links going to the same service provider. The first link is going to be left as the local preference default, which is 100. And the secondary link, we're going to apply a local preference of 200. And that's going to be our primary link going towards the carrier. And on our left, we got the carrier router. We got the two links going towards the customer router on the other side. The first link is going to be left as the local preference default of 100. And the secondary link, which is going to be the primary link as well, we're going to be applying the local preference of 200. So here's the configuration that is going to be first applied to the customer router. We're going to configure the interfaces that are going to be serving as WAN links. We're going to configure the loopback interfaces, which are going to be serving as the local LAN. We're going to configure the roadmap, which is going to set the local preference of 200. And we're also going to configure the routing protocol BGP. And in our left, we're going to do exactly the same thing. On the carrier router, we're going to be configuring the interfaces that are going to be acting as WAN links. We are also going to configure the loopback interface, which is going to be acting as the local LAN, the roadmap, which is going to set the local preference of 200, and also the routing protocol BGP. So now that we have explained the BGP attribute local preference, let's dive into the lab and let's get it done, guys. All right, so we're inside the CML now. We're gonna start configuring the customer router. We're gonna configure all the interfaces, the routing protocol BGP, and also the route map with the local preference of 200. Let's get started. Alright, so now that we finished up the BGP configuration and all the good stuff on the customer router, we're gonna proceed now to jump to the carrier one. As you can see, I haven't applied the route map yet. This is gonna be done later on. So we're now jumping to the carrier router. Let's proceed with the configuration. So the reason that I did not apply the route map at the beginning is because I want you to see that the first knot that comes up is the actual knot that the BGP is going to state as the best path for inbound and outbound traffic. But that's going to change after we apply the route map to the secondary link. So if I do a show IP BGP, you're gonna see that the best path to reach the 10.1.0.0/24 and the 10.1.1.0/24 is gonna be via 192.168.1.2, which is the primary link between the carrier router and the customer router. So we're gonna now proceed to apply the route map on the inbound and the outbound direction on the secondary link, which is 192.168.2.2. Alright, we're done in the carrier side. Let's go to the customer side now and apply the route map to the secondary link as well. Alright, so let's do a clear IP BGP asterisk soft in and soft out to speed up the process to apply whatever is inside the route map. Now let's go to the carrier router and let's do a show IP BGP, and as you can see, now everything changed. Now to reach the 10.1.0.0/24 and the 10.1.1.0/24 is gonna be via 192.168.2.2, which is the link that we actually apply the route map with the local preference of 200. And remember that the rule states that when choosing a route within an autonomous system, the path with the highest local preference value will be preferred. Alright, let's go ahead and jump into the customer router. Let's do a show IP BGP, and as you can see, the best path to reach the 192.168.255.1/32 is via 192.168.2.1, which is the secondary link. So let's do a show IP route, and as you can see at the bottom, 192.168.255.1 is reachable via 192.168.2.1. So let's go ahead and do a ping test to the 192.168.255.1. It responds, and let's do a trace route to the same IP. And as you can see, it's taking the 192.168.2.1 to reach that destination from the customer side. So that's all for today's video. I hope you enjoyed the content. If you did, please give it a like. And as always, this is Julio. I see you on the next one. Peace out.